Inheritance in Python. What is inheritance? How do we do it? In this lecture, we'll discuss the various types of inheritance like single, multiple, multi-level, hierarchical, and hybrid. We'll also see the super function and discuss method overriding and overloading. This is a person. This is a student. But this is also a person. A student is also a person. Let's understand this with a UML diagram. UML stands for Unified Modeling Language. Say we have two classes, student and person. Student inherits from person because a student is also a person. Bottom to top, this is generalization. A student is also always a person. Top to bottom, it is specialization. A person may be a student. In this relationship, person is the superclass and student is the subclass. Person is the parent class and student is the child class. Person is the base class and student is the derived class. Python is an object-oriented programming language and is able to model the real world. So let's see how we implement this in it. We have classes person and student, but we don't know what to do with them yet, so we put past statements in them. Student inherits from person. The subclass function lets us check whether one class is a subclass of another. Is student a subclass of person? Yes, it is. We have 5 types of inheritance in Python: single, multiple, multi-level, hierarchical, and hybrid. Let's start with single inheritance. A single class inherits from a class. Say x is 0. Classes fruit and citrus modify the global variable x. Fruit increments it by 1 and prints I'm a fruit. And citrus increments it by 2 and prints I'm citrus. Citrus also makes a call to the init of the class fruit first using the super keyword. Now, lime is an object of the class citrus. Simply creating this object prints the lines I'm a fruit and I'm citrus. If we now globally print x, we can see that it has been incremented by 3. In this example, citrus is a fruit. We have one base class and one derived. This is single inheritance. Multiple inheritance is when a class inherits from multiple base classes. We have 2 base classes, color and fruit. The class orange inherits from both of these. Is it a subclass of the classes color and fruit? Yes, it is. Orange is both a color and a fruit. Here we have multiple base classes and one derived. This is multiple inheritance. And if one class inherits from another, and this inherits from yet another, we have multi-level inheritance. Class footwear inherits from class accessories and stilettos inherit from class footwear. In class accessories, size is 7. Giuseppe Zanotti is an object of class stilettos. What is its size? Now here, the class stilettos does not have a size attribute, but it does inherit one from footwear, which first inherits it from accessories. So size for Giuseppe Zanotti is 7. Stilettos are footwear and footwear are accessories. This is multi-level inheritance. Footwear is a base class for stilettos, but a derived class for accessories. And when multiple classes inherit from a single base class, It is hierarchical inheritance. Classes winter wear and socks inherit from class clothing. Both are subclasses of the class clothing. Here, winter wear and socks are types of clothing. We have one base class and multiple derived classes. This is hierarchical inheritance. Any combination of more than one type of inheritance can be called hybrid inheritance. The child inherits from the mother and the father, and they inherit from the class parent. They are both parents. And a parent always has hazel eyes apparently. Rowan is the child. What is the color of her eyes? Hazel. Because she inherits it from both her parents, who have hazel eyes, because, well, all parents have hazel eyes. This is a nice example of hybrid inheritance. This scenario also forms the diamond of depth, but we'll see that when we discuss multiple inheritance. In one of these examples, we used the super keyword to make a call to the parent class's init method. What is it? Well, the super function lets us refer to the parent class to call a method. If a class has a method that's also present in the parent class, calling it with super lets us access the version in the parent. The athlete warms up and sprints. The champion gloats about warming up, being a champion, and sprinting. Usain Bolt is a champion. If he gloats, he says, I am warming up, I am a champion, I am sprinting. The gloat method made the call to the warming up method in class athlete, and so did sprinting. Method overriding and overloading. If a subclass provides the definition for a method also present in the superclass, it redefines the functionality of this method. Both classes Bob and Alice have the method say hi, but since Bob inherits from Alice, his version of say hi changes it to I'm Bob. If we create an object of Bob and call say hi on it, it prints I'm Bob. It doesn't print I'm Alice because it has replaced its contents. It has overridden the definition of the method say hi. Unlike C++ or Java, Python does not support method overloading. We have two methods with the same name, add. Assume that these are in a class and not a stray. One of these adds two numbers, the other adds 3. What is add of 2 and 3? While it should have taken the first definition to add the two numbers, it doesn't. It now only knows one definition of add, one that takes 3 arguments. Add has been redefined. And what if we have just one version of add, but with C as a default argument with the value 0? This still isn't overloading. But we know what to do. We use an argument instance of to tell the method whether to prepare for integers or strings. If it is int, result is 0. And because we've used arbitrary arguments, we can pass any number of integers. If str, result is an empty string. Now it adds or concatenates each value to result and finally returns it. We're trying to add 3, 4 and 5 and it works. Can we use it to concatenate strings? Sure. This was all about inheritance in Python. Stay tuned and we'll dig deeper into multiple inheritance next.